Welcome back. Today we're going to look at operations on polynomials, specifically adding, subtracting, and multiplying. But first off, to review, we are going to take a look at properties of exponents. So if you have the handout from class, there is a table to go ahead and fill out. So go ahead and copy that down while I go over it. So a monomial is a number or variable or a product of numbers and variables. So examples could be 4, 7x, 3x squared, and so on. We have these exponent rules that should be reviewed. Doesn't mean they are, but they should be. Our first one is product rule, and that when we multiply variables, the same variable, we would add the exponents. So our example, x to the 7th times x to the 9th would be x to the 16th, because 7 plus 9 is 16. Power rule is when we raise the power, meaning we're raising the exponent of an exponent, and we would multiply. So b to the 5th time to the 4th power would be b to the 20th, because 5 times 4 is 20. Quotient property or quotient rule is when we're dividing the variable of the same variable, and we're going to subtract the bottom from the top. So t to the 7th over t to the 3rd would be t to the 4th. Negative exponent rule is basically saying that we're not allowed to have negative exponents, and that we would need to go ahead and take the reciprocal of that term and go ahead to cancel out the negative exponent. So if I had v to the negative 7, that'd be the same thing as 1 over v to the 7th. If I had 3 over v to the negative 4, that would be the same thing as 3 to the v to the 4th. You're only going to move the term that has the negative exponent. So if the variable that has a negative exponent. So if it doesn't have a negative exponent, it stays where it is. And then we have zero exponent rule, which basically says anything to the 0 power is 1, with the exception of 0 to the 0, and that would be undefined. Essentially, the zero exponent property rule is a extension of quotient rule. That is, if your variables were the same, if you had the same top and bottom, they cancel out and you're left with 1, so they reduce to 1. I would like to stress, though, that when we add or subtract monomials, you combine like terms, which means you leave the variable and the exponent alone, and you only touch the coefficients. So we have a couple examples. 95, yeah, that's right. So what we're going to use the properties of exponents. So I do want you to go ahead and try these on your own, and we'll come back together to check your work. Since it should be a review, I like taking that word should, doesn't mean it is. But let's go ahead and check your work, pause if needed. So 5 times negative 7 is negative 35. 2 plus 6 is 8, so negative 35x to the 8th. I'm going to do all the odds first. So we're going to divide by 3 first here and get 16. You're going to leave the variable where the larger exponent is. So my larger exponents are in the top. So 6 minus 2 is 4. 4 minus 1 is 3. Since they have the same variables with the same exponents, we can combine like terms and get 6m to the 4th and cubed as my final answer on number 3. I'm going to get rid of this exponent up here first. So 4 over 9, we're going to square. 2 times 2 is 4. 7 times 2 is 14. 1 over 6 r cubed s. So we're going to get 4 over 54. 4 plus 3 is 7. 14 plus 1 is 15. And we are going to simplify this to 2 over 27. And we can actually extend this out to the 7th s to the 15th. So I can either write this as 2 over 27 and then my r and s on the side, or I can write them all in the numerator. That works. Number 7, we're going to have, this is going to stay a fraction. 15 and 24 are both divisible by 3, so 5 over 8. X has a larger exponent, so it stays in the bottom, I'm sorry. X has a larger exponent in the bottom. So 12 minus 10 is 2. Y has a larger exponent on the top. 4 minus 3 is 1, so we leave it as is. For my evens, we're going to square first. So we get 4a to the 6b squared times 8ab to the 9th, which would get 32a to the 7th, b to the 11th. We're going to get 14k to the negative 3, because 4 minus 7 is negative 3. Oh, this is not 14, this is 20. Which would be equal to 20 over k cubed, because we're not allowed to have negative exponents. -1 just flips. When we have a -1 like this on the outside, it flips the exponent or the term. So we get 7w cubed over 14w to the 12th. 7 divided by 14 is 1/2. W 12th is larger, so 12 minus 3 is 9. Let's go ahead and distribute the 4s, the exponents first. So this is c to the 4th over c to the 8th times 81 c to the 4th. So we're going to get 81 c to the 8th over c to the 8th, which is just going to get me 81 for my final answer. So again, pause the video as needed, but that would take care of our properties of exponents. Number 9 is basically saying the answer is -3n squared over m. Give me an example of what could have been my question is what they're asking. So an example could have been -36m to the 4th, n to the 7th over 12mn, m to the 5th, and n to the 5th. Because when this simplifies, you will get -3n squared over m. But there are infinitely many answers to this question. So you can submit answers, see if we all agree or not. Up to you. All right, polynomial is a sum or a difference of many monomials. The highest exponent of the polynomial is called the degree. Standard form always writes the exponents in descending order, big to small. So that's one of the biggest things that we're going to take a look at. Very important that we do that. So on number 10, my highest exponent is 5, and then 3, and then 2, 1, and 0. So this is the order I need to write them in. So -k to the 5th, -3k minus 3k squared plus 1/4 k squared plus 8k minus 1. Oh, I should have said minus 3k cubed, not squared. On 11 and 12, we typically don't see these when we talk about polynomials in Algebra 2. This might be in a higher degree of math class. But when we're doing standard form, when there's more than one variable, we do alpha order and then exponent order. So we're going to do everything that has an a in it first, from big to small for exponents, and then we do the b's and then the constants. Our last term is always our constant. So this is really saying 1 minus 1 x to the 0, but x to the 0 equals 1. So that's why we don't actually put the x to the 0 in there. But that is why we always have the -1 at the end. We say that's our 0 exponent. So checking your answers for 11, you should get 4a cubed plus 18a squared, b squared plus 7ab minus b squared. And on number 12, we should have 9x cubed y minus x squared plus 5xy squared minus y to the 4th plus 2. So again, notice that everything that has an x comes first before we start going with the y to the 4th, because even though it has a higher exponent, alpha order, it doesn't go first. So classifying polynomials, so we have degrees, and these are probably terms you've heard in a math class, maybe in just not expressly calling them the degree. So the degree would be, my example, this would be y equals 5. So this would be a constant function. Next, we have linear. So this again would be my highest exponent, so 1. So this would be like x plus 2. Quadratic function, and that's where we start getting a bit more familiar, would be anything with an x squared as the highest exponent. The highest exponent being a 3 would be a cubic. Highest exponent 4 would be quartic, and then quintic for 5. Typically, though, I would say that once we get to powers 4 and above, we usually just say to the 4th power to the 5th power. But just know that if they are referencing quartic or quintic, they are going to mean 4 or 5. Now, the number of terms, again, these are also things that you've heard in class, which we've already talked about. A monomial, because mono means 1 for us. Binomial would be 2. Trinomial, 3. And anything above 3, we're going to call a polynomial. And this is just the number of terms that we're adding or subtracting. So we're going to take a look here. We're going to take a look at number 13, and then I'll let you guys go ahead and try the rest. 13, so it says classify by degree and the number of terms. So the degree here, the highest exponent I have is a 1, so this is going to be a linear. And I only have 2 terms, 1, 2. Binomial. So based on the number of terms and then the degree, go ahead and identify, or the vice order. So go ahead, pause the video. 19 and 20 is you coming up with your own answer. So pause the video, give it a shot. Let's check your work. You should have a quintic trinomial. We should have a constant monomial. Sixteen is a cubic polynomial. 17 is a quadratic. You know what, how about if I can spell quadratic right? Quadratic. Trinomial. We have a quartic monomial. An example of a cubic binomial, 58x cubed minus 2. An example of a linear monomial, 7x. Now there are infinitely many answers I could put on there. Like I could have done negative 7x. I could have done x. I could have made this a plus 2. Could have made that a 2x. So many possible answers that we could have. But those are just a couple examples of what we could have that would work for that situation. So moving on to our operations, specifically add, subtract, and multiply. When adding and subtracting polynomials, we're going to combine like terms and write our answer in standard form. So I want to stress the importance of us writing in standard form, that's explicitly given in the directions. The expectation is that we are writing in standard form. And that's because it is the standard form that is that everybody in the world will understand when you write in this order. So one thing I like to do is I actually like to stack my problems rather than doing them horizontally, just because I like everything lining up. So like I would move that -2n squared to the bottom and just line them up. So when we're adding, everything's great because I don't need to worry about any sign changes. We're just going to go with what we have. So 9n cubed, -4 minus 2 is -6n squared. We're going to leave the variables and exponents as they are. 2n plus n is 3n. -7 plus 7 is -3. Oh, and look at that. I did have a click through on this. On number 4, one thing I would do, I would completely rewrite this so everything is in standard form. And because we're doing subtraction, it does matter which one goes on top and which one goes on bottom. So we're going to go ahead and make sure we put the -1 on the bottom. And then we're going to go ahead and put everything in standard form so that I don't have to worry about it later. One thing I do suggest is actually distributing this negative to everything on the inside, because the further away you get from that minus sign, the more likely you are to forget that you're actually subtracting instead of adding. So if you distribute that negative, you no longer have to worry about that. So we're going to get y cubed minus 2y squared. That should be a plus. Yeah, that should be a plus. Plus 6y minus 4. I need to fix that. So I'll get that fixed. But that should be a plus 2y squared. Now, if you have the handouts, I want you to go ahead and try questions 1 and 3 on your own. If you don't, I am going to go ahead and switch to that slide. So go ahead, try these. All right, let's check your answers. You should have had negative, that's the y, 4x squared plus 6x minus 9. On number 3, you should have had 5k cubed. Those cancel out. $2k minus 2k. Oh, those do not cancel out. The 2k's cancel out. We should have minus 4k squared minus 17. Right. Go ahead and try number 5. So this is actually going to be minus, I guess I should line them up. So for the setup on this one, check your work. We're going to do negative 2a squared plus ab plus b 8b squared. I'm going to distribute a negative sign to all of these. So this becomes plus 10ab plus b squared minus 7a squared. The reason that happens is because we're subtracting, so I'm going to switch all my signs. And it doesn't matter what you're subtracting from. So here we're going to have negative 9a squared plus 11ab plus 9b squared. Multiplying. Now this is where we get a little different topics in what you may have been exposed to for multiplying. You may have done distributive property, you may have done box method, you may have done FOIL. Typically, we are going to stick with a box and fill out the box. We like it just because it organizes your thoughts a lot better, especially on some problems where you might not have actually multiplied everything you needed to. So we're going to go ahead and go over here. We're going to do a box. We're going to do negative 3 times a plus 5 first. And we distribute that, negative 3, and we get negative 3a minus 15. We're also going to go ahead and do a second box of a minus 2 times a plus 8. And fill in our lovely box by multiplying. I will say the biggest thing I want to stress is making sure that you remember that on this last box here, that we are multiplying. I've seen several times where people add or subtract for whatever reason, even though they multiplied everywhere else in the box. So from the two boxes, we get negative 3a minus 15 times a squared plus 6a minus 16. So we're going to do another box, a 2 by 3 in this case, and multiply through. And we're going to combine our like terms to get 3a cubed minus 33a squared minus 42a plus 240 as our final answer. So I do want you to go ahead and try questions 6, 7, and 9. All right, let's go ahead and check your work. So here is the box we should have had for number 6, with our final answer being w cubed minus 5w squared minus 13w minus 7. On 7, here is the first box and the second box. So from the boxes, we get negative 18x squared minus x plus 4 minus 6x squared plus 22x. And combining like terms, we get negative 24x squared minus 23x plus 4. And on 9, I want to stress that making sure that we understand that this is really 2c plus 5d times itself 3 times. So I do have a little cheating here. It's not really cheating. If you recall from quadratics, our perfect square trinomials pattern. So I use that to my advantage and do a box. and get 8c cubed plus 60c squared d plus 150cd squared plus 125d cubed. I want to say I do have a second version of this. Here it is. Here's our second version where it does actually, I do, in case you do not recall our perfect square trinomials pattern, where I do go over having the pattern here in the box for what we need. And again, you still get the same answer, just a bit more work. And that is actually the end of the lesson. So hopefully that helps you guys out, and I will see you guys next time.